Okay, hello. Let's start with homework. Homework 8. I don't want to read whole question. I will go one by one, explaining my work. What is deterministic Q automation? DQA. DQA is similar to deterministic push-down automation, except that instead of stack we have Q, and the queue allows symbols to be added only the left hand end. I'm in the push automation, and the queue allows symbols to be removed only from the right hand end. Okay. Additionally, like push down automated deterministic queue automation has read and input tape where input head moves strictly left to right. Okay. There is a blank symbol at the end of the input, so the automation can detect end of the input. In each step in deterministic automation, let's look at the current state, and after that looking at the current input symbol. And after that, third one is will gonna be symbols at the right hand end of the queue. Okay, 1, 2, 3. Therefore, decide to push a new symbol onto the left end of the queue. I mean, remove the symbol from right end, or do neither. This was first step. I don't want to write whole thing. I just want to mention. The 5th step is we're gonna be move to this step, and 6th step advance the input head to the right. If there is more input, the deterministic automation accept if enters an acceptance state with the input and Q in the right connection depending on the definition key idea, simulating by simulation by Turing machine. Turing machine can simulate any model with limited or structured memory like Q, but by systematically representing that memory on its tape or tapes, that can be done one tape. The main question is we're gonna be how we store and manipulate data on the Turing machines. It's representing the Q Turing machine type a second. It can be Q seconds of symbol where new symbols are added on the left, symbols are removed from the right rear. In front, new symbols are added on the left. In the rear, symbol are from the right. And after that, let's show how can we store seconds on Turing machine tape from left to right, for instance. Okay, Sorry. This one will gonna be left hand push. This one is right hand push. Q1 to Qn represent the symbols currently. And I just thought a Turing machine can insert and delete tape symbols by shifting data left or right if it's a single tape turn Turing machine. That this is coming from the lecture, or by writing blanks over symbol and rearranging as needed. Okay, using multi-tape, Turing machine can make the even clear. On a tape, for one tape for input, another tape to store Q symbols, and possibly another type for the control logic. But even a single tape Turing machine we can do it, okay, but because they all have same power, this is same power all Turing machine, but it is not equal with the same speed. Same power is not gonna equal to same speed. Tape movement become more elate. Simulating and after that simulating one, let's write here simulating one deterministic Q automation step on the Turing machine. And after that is simulating one deterministic Q automation step on the Turing machine. Single step in the deterministic automation depends on the current state of the deterministic Q automation. The current input symbol and blank. Thirdly, the rightmost symbol of the Q, or nothing if the Q is empty. Okay. If we think this deterministic Q we are pushing the add symbols to the left hand. Okay, remove the rightmost symbol and move into the input head one step to the right unless input is finished. A transition to a new state to the Turing machine. We are storing the deterministic Q automation current state somewhere in Turing machine state or finite console. If we represent states as part of the Turing machine console, we read the current input symbol and we locate and rightmost Q symbol, scanning where Q symbols are stored according to the deterministic sequence automation transition functions. We perform corresponding push or pull operation on the tape. Mean we move the input head right by one cell if needed. We update the store current state of the end state. Thus, each single deterministic sequence automation transition can be broken down into finite number of Turing machines move. Scanning, writing, erasing, or shifting. Okay, and after that, detailed simulation step. Less detailed initiation determine the next transition. Perform the Q operation. Move to the input head. Update the state. Accept or reject. Let's write it. Initialization the Turing machine starts with the blank Q region, just a border marker, sharp OK from C, and Turing machine writes the deterministic Q start state and Q0 maybe, and some design location, and Turing machine's input head at the leftmost symbol of the input, and determining the next deterministic Q transition. Current machine the Turing machine reads the current state. Then after that current input symbol. Then after that I'm just thinking. The third one is the symbol at the right end of the queue. Okay. From this, let's look up the appropriate deterministic queue transition. What symbols to push, if any, whether to pull the end state, whether to move the input. Okay. Then after that we are doing the perform the queue operation. If pull is required, the Turing machine erased the right MQ symbol from its tape. This can be done by moving the symbol and writing a black, then shifting tape content if needed. If push is required, Turing machine insert a new symbol push just to right and left boundary and sharp symbol. Okay, like that. And the Turing machine can shift the queue content one cell to the right if necessary, and writing the new symbol, it's located the cell. Okay, then we are doing moving the input head. Move the input head. If the deterministic queue transition cells for advancing the input head, the Turing machine, let's call TM, moves the input tape head one cell to right. Okay, in a single tape scenario, it means carefully returning of the input region and moving that head to right. And after that, updating the state. After the Turing machine overrides the old state or updates its control to record a new deterministic queue automation state. Then after that, accept or reject. If deterministic queue automation enters the acceptance state and possibly after finishing the input if they required TM transitions, Turing machine transitions to its own accept state. That's it.